Good day, I'm Felix Kema from Nigeria. I'm here to make a PPT presentation on the overview of data science and its applications. So, going straight to the presentation, I'm here talking about, first of all, defining data science. So, with the definition here, data science can be defined as the science or art of collecting, cleaning, visualizing, analyzing data with the aim of drawing insights from it. And the data collected are messy data that are gotten from different data sources, which are collected with the use of some data science tools like SQL and Excel. Data scientists derive valuable insights from this messy data and helps organizations find valuable insights from it by making predictions. This definition can be found in Data Science from Scratch by Joel Cruz. Data science is a field that mostly deals with data, and with the data is analyzed and the data is also visualized to be able to get more insight of it. These data are cleaned and all null values in the data are being removed, all the duplicates are removed, and names or elements in the data which are not well named are renamed. So data science is that science that deals mostly with data of different sources, data of different companies, data of different, name it, different sources, and these data has many informations in it which when analyzed tries to give good information, good insight about the particular aims at which it is being analyzed. So moving forward, you can see data science is a multidisciplinary field that combines principles and practices from the field of mathematics, statistics, artificial intelligence, and computer engineering to analyze large amounts of data. Data science employs mostly science of mathematics, statistics, and not just mathematics and statistics. It also employs science of machine learning, deep learning. And when we talk about machine learning and deep learning, we are now moving into artificial intelligence, and it also employs some science of computer engineering. All these science of mathematics, statistics, artificial intelligence, and computer engineering are being combined together in order to analyze the large amount of data. When all these sciences are combined together, they helps in analyzing, visualizing, and giving a good prediction of what the data is saying. It tries to give an insight about the messy data that was collected. So data science is not just a field, but it's a multidisciplinary field that combines all these different disciplines together in order to achieve its aim. Data science is made up of four major types, namely descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. So let's look at descriptive analytics. Descriptive analytics involve analyzing what has happened in the past. It focuses on summarizing historical data to understand what has happened. Its primary goal is to provide a clear and concise summary of the data, enabling researchers and analysts to gain insights. It also involves a graphical representation of data through charts, graphs, and tables. In descriptive analytics, the data so collected are being used in trying to know the events that have happened in the past. It tries to give a kind of summary about the history of what has happened based on the information found in the data. So descriptive analysis is that type of data science that is being carried out in knowing the previous things, events, happenings that have occurred in the past. So moving down to the next we talk about prescriptive analytics. Prescriptive analytics is a type of business analytics that uses data to suggest the best course of action for a situation. It makes use of data analytical strategies, machine learning, and other computational modeling to stimulate strategies and make recommendations. It requires a combination of technical, communication, and business skills. It's one of the most complex and errors-prone types of data science. Prescriptive analytics tries to use data to suggest the best course of action. It tries to give a kind of an analytical strategy. When it tries to make use of machine learning and computational modeling, it tries to tell more about what the data is trying to say, the information about the data. It tries to give more insight about what the data is given concerning an organization or a company. Moving to diagnostics analytics. We say diagnostics analytics is a data analysis technique that uses past data to identify the reasons behind events or outcomes. It examines data to understand the root causes of events, behaviors, and outcomes. This type of data science tries to use the messy data being collected to analyze and gain more insight about the outcomes of an event, how the behaviors of the event was, what really happened during the event, and the possible outcomes of that very event after the analysis. Then we move to the last one, predictive analytics. Predictive analytics is the process of using data to forecast future outcomes and trade outcomes. It uses mathematical and statistical models, machine learning, artificial intelligence, and data analytic patterns to predict future trends. In predictive analytics, the data collected are being used to predict future trends. Future trend in the sense that the data is being used to make a kind of future prediction. For example, in predictive analytics, you can talk about the stock prices, or you can make mention of, let me use Bitcoin for example. So if you are having a kind of messy data about different coins, prices of Bitcoins in the market, so you can do a kind of predictive analysis in trying to know the future price of a particular Bitcoin, taking note of the different prices that have been in market for a long while. So when you are trying to make an analysis about the Bitcoin prices in predictive analytics, you can try to predict the future price. So that is what predictive analytics try to do in data science. So data science in general is a demanding field growing every day. Its root can be traced back to the 1960s and 1970s when computer science and statistics began to intersect. Data science is a field that does not really make use of only computer knowledge. Rather, data science encompasses computer and also make use of more of mathematics and statistics, and also business intelligence. The term data science was invented by Peter Null in the year 1974, while William S. Cleveland is credited with establishing data science as a separate discipline in the modern era. You can get that in Google Icon 2011-24. John Tukey is regarded as the father of data science. Now, we have different, if you go through the slides, we have different rules in data science, data collection, data analysis, data visualization, machine learning. But to straight to the main purpose of this presentation, I am going straight to the applications of data science. So if we are going to the application of data science, we try to see that data science is applicable in many disciplines, And one of the major sectors at which data science is very applicable is in the health sector. Data science application in the health sector. Data science is applicable in the health sector in different ways. One, in predictive analytics, in early detection of diseases, in disease prevention, personalized treatment, in managing the hospital, that is hospital management, in medical imaging. So you try to look at it one by one. Predictive analytics. Data science can use historical and current data to make predictions about patient outcomes, disease outbreaks, and at-risk patients. For example, predictive models can help identify patients at risk for sepsis, which has led to lower mortality rates. Data science tries to gather information from the spread of a particular disease and also tries to gather information at the rate at which the disease is being spread, and also try to gather information on how often the disease is being spread. So from using predictive analytics in the health sector as a type of data science, you can always predict the spread of a particular disease. For example, during the time of COVID-19, when the COVID-19 came into the world, there was a lot of data that was being collected day by day, and with the help of data science, they were able to make some predictions on how the disease is being spread, the possible positive outcomes in the disease, those that have been diagnosed of the disease, and those that have been treated. And with the help of this predictive analytics, different countries were able to know the number of patients that have been affected with COVID-19. They were being able to know the number of patients that were being quarantined. So predictive analytics was a good type of data science that was being employed in the health sector to cure or to try to cope with COVID-19. So predictive analytics is one of the major types of data science being applicable in the health sector, which help the health sector a lot. Then early detection. Data science can help detect chronic diseases early, such as the COVID-19 when it comes to scan. Like currently now, the COVID-19 are come to stay, and in every hospital you go to, when you want to run a test, they always test you of COVID-19. And someone that is always going for a test and you are being diagnosed of different diseases, and you too also run scans. Now from the scans you are running, if there is any symptoms of COVID-19, with the help of models that have been built and being used by the hospital, if any sign of COVID-19, it will be detected, and with that the disease will be detected early and further health procedures will be taking place. So it's one of the major ways at which data science helps the health sector. Then disease prevention. Data science can help identify patients at higher risks for diseases, which can help improve prevention efforts. Disease prevention. Data science tries to monitor the spread of a disease, because in order to prevent a disease, you also need to monitor the rate at which it's spreading, just like the case of the COVID-19. One of the major ways at which the world was able to cope with COVID-19 was how they monitor its rate of spread, and you can perfectly do that with the help of data science. When you're trying to take data of affected patients, you try to take data of quarantine patients, you try to take data of diagnosed patients, you try to take data of patients that have died as a cause of COVID-19. So with the help of all these data, you try to take data of suspected patients which are believed to have the disease. So by the time you take all these things and make predictions and analysis with them, you will notice that the sector will be able to indirectly prevent the disease from either spreading or being contacted from by other source. Personalized treatment. Data science can help personalize treatment based on the patient genetic profile. Then hospital management. Data science can help optimize hospital management and operations, such as resource allocation and reducing manual errors. With the help of machine learning models, artificial intelligence, and some deep learning, different management in the health sector have tried to make use of these models in managing their hospitals, and this management tries to handle most of their sophisticated databases, which try to reduce manual errors. So if you are, for example, having a hospital that have up to like 2,000 staffs, and these 2,000 staffs, they have their different data that are being entered by different personnel, and each of these personnel are handling health informations of different patients. So there is always this very possibility that there will always be human errors coming in. So with the help of data science, you can create a database for this hospital, and by creating a database for this hospital, each staff in the hospital have their columns, each patient in the hospital have their columns and their rows. So with that, you'll be able to be entering their data each day, and with so doing, you'll be able to, after a while, create a large database which can also be further analyzed and give you good information about the management of the hospital. So moving to medical imaging, data science can help detect early signs of cancer in medical images. This can be done through artificial intelligence or machine learning models, which will be used to monitor, scan in maybe X-ray or scan for cancer. So the model will be built in a way that once a sign of cancer have been noticed, the model give a kind of prediction of the possibility of cancer in such a person, and that will be reflected on the image. Apart from the health sector, data science is also fully applicable in the financial sector, and in the financial sector it can be applicable in algorithm trading, price optimization, fraud detection and prevention, credit allocation, risk management and analysis. So looking at it one by one, algorithm trading. Algorithm trading is a process of executing orders using automated pre-programmed trading instructions to account for variables including volume, time, and price. It can channel massive amounts of data into streamlined insights, enabling financial institutions to make more accurate and effective predictions about financial marketing. In algorithm trading, using the crypto market for example, in algorithm trading, we can build a machine learning model or make use of an artificial intelligence system whereby the system or the model tries to make possible predictions of the price of a particular cryptocurrency in markets. You can also use this model or this artificial intelligence system to monitor the rate at which a particular currency in the crypto market is growing, and with this you will try to have a good knowledge of how the market is moving both positively and negatively. And if you are a good financial analyst, with this knowledge being given to you by this model, you'll be able to make good predictions and make good trading, which can help you in maximizing profit. So this is one of the major method that data science has been applicable by financial analysts in the financial sector in trying to trade the market. Secondly, price optimization. Financial institutions can leverage data analysis and machine learning to pass on access competitor pricing and market demand, enabling them to optimize prices for their products and services. Then let's move to fraud detection and prevention. Fraud in the financial industry can include identity theft, creating a fake bank account, applying for a loan under a false name, direct theft of funds, money laundering, attempted tax evasion, and speculator trading. Because the financial world and the efforts to take advantage of it moves in real time, the organization fraud detection must move in real time too. Now, with the help of machine learning systems or even artificial intelligence system, with this algorithm, you can try to build a model whereby data of people will be detected. Now, for example, if you go to a bank and a banking institution where customers normally go to run their data, if they want to open a bank account, they put their BVN, they put their national identity card, they thumbprint, and their footprints are being taken. When customers go to these banks to bring up their personal identities, their personal informations, these banks takes their data. So with the help of machine learning models, if a model is being built and used by these banks, if any personnel who is not a direct person comes to claim an account that is not his or her own, with the help of this machine learning model, it will be able to detect that this very particular person is not actually the true owner of the account. Reason being that the original account owner is not being detected by the model. So if the original account owner comes to make any transaction, the model shows that yes, this is a true account owner. But when a false person, a fraudster comes in, maybe in trying to foster or to make another document which is not its true copy, the model tries to make a prediction that no, this person isn't the right owner of this account. So with this method using machine learning and artificial intelligence, data science tries to make a good application in financial sector, and it's one of the major process that most of the countries are using in controlling and preventing fraud in the financial sector. And that's why if you come to like country like Nigeria, we have the Economic Financial Crime Commission, EFCC, where they try to make sure that they arrest most of these fraudsters. And one of the method they are using is this data science method, where they try to make use of artificial intelligence and machine learning models in controlling the rates of fraud in the banks. So moving forward, we have a credit allocation. Nearly everyone today has a digital footprint, a unique tray of traceable data you give when using the internet or digital devices. This data, including one's digital activities, contributions, communication, and actions, can be examined by machine learning algorithms to reveal relationships between factors and customer behavior. This can in turn affect credit allocation by predicting how likely an individual is to pay back a loan. I think this is very understandable. Then risk management and analysis. To analyze credit worthiness, financial institutions can leverage machine learning algorithms to analyze customers' transactions, histories, and behaviors. This information can be used to assess the likelihood of a borrower defaulting on a loan, which can help organizations make strategic decisions to manage risk and increase security. There is this data set I worked on earlier, and the data set was strictly for a company who gave some personals loan, and the company giving them loan were unable to put the loan on a monthly base, where they are going to have of a kind of a profit. What I mean by a profit, like each of the month they are going to pay additional money on the loan that they borrowed. And now the data set, when after being analyzed, I noticed that the company is going to make a loss because the company were unable to have a full information about each data of the persons they borrowed. I noticed in the data set that each of the personnel that borrowed, some of them are almost to be retired, and the money that they borrowed were very huge, which they can't even pay with their salary. So with their with their predictions, it was also noticed that most of them are even up to age, and most of them will be retired, and the money being borrowed by them can never be paid. So with the analysis, it was shown that there is no how most of 80% of the personnel that borrowed money will be able to pay the money. So assuming the company employed data science method in trying to cope the rate at which they borrowed their loan, there won't be any way they will make loss. So what am I trying to say? Risk management is very, very important, and it's very, very necessary in the financial sector, just as to at least control the rate at which people take loans and won't pay. Trying to also study the history of people who have been borrowing money and have been paying, and trying to also study the behaviors of how people borrow and how they paid. So this most of the applications of data science that we have numerous applications of data science. It's also used in geometrics, in geoinformatics, and even in GIS. The data science also used in transportation. Companies like Uber also uses data science in tracking locations. Even the GPS also makes use of some functionalities of data science, where they make use of some machine learning models to track positions. It's also applicable in voice recognition and many other disciplines that make use of data science. So with this, I hope you have been able to learn something today, and I thank you for listening. Thank you very much. You're welcome.